Now, here we want to solve simultaneous equations using matrices. So what we are saying is that before you solve simultaneous equation using matrices, you first extract the coefficient of the variables. Variables here is A and B. So the coefficient of variable A is 3, the coefficient of variable B there is 2. The coefficient of variable A here is 4, and the coefficient of variable B here is -1. So that gives us the coefficient matrix. That is coefficient matrix. Then the variables will form a column matrix using the variables. So you must ensure that the variables here are the same variable and the variables here are the same. So the order of the variables is very important. So that when A is here, then A will be on top, and B is here, B will be at the bottom, the lower end. And that one should equal to 12, 5, which is also another matrix there. Another matrix there. Now, having extracted the coefficient matrix, the unknown matrix, and the solution matrix, then we find the inverse of the coefficient matrix. And the first thing to do is to find the determinant. So the determinant should be -1 times 3 minus the product of elements in the other diagonal, which is 4 times 2, so that is 8, and therefore our determinant is -11. That is -3, so our determinant is -11. So we get now the inverse, and inverse is 1 over determinant times the elements of the matrix when the elements in the leading diagonal are altered. So there we have -1, 2, 4, 3. And then we negate the other elements. So our determinant is 11, so we have 1 over -11. So we multiply here by -11, and then you get 1 over 11, 2 over 11, -4 over 11, and 3 over 11 as the inverse of this matrix. So we pre-multiply. So here, this multiplied by this should give us +4 over 11, and this will be -4 over 11. So we are now going to pre-multiply by the inverse. In other words, you write the inverse first. That is 1 over 11, 2 over 11, 4 over 11, and -3 over 11. We are multiplying by the matrix, which is 3, 2, 4, -1. Our unknown matrix is AB, is equal to the inverse, which is 1 over 11, 2 over 11, 4 over 11, and 3 over 11. And the solution matrix is 12, 5. So previously, we had learned that a matrix times its inverse is identity matrix. Therefore, this multiplication here should give us 1, 0, 0, 1, which is the identity. So it's very important to remember this concept that a matrix times its identity times its inverse will give us the identity matrix. And that is A, that is B. So the only work we are left with is to do this multiplication here. So we have 1 over 11 times 12, and that is 12 over 11, plus 2 over 11 times 5, and that is 10 over 11. Then we multiply this, that is 4 over over 11 times 12, that is 48 over 11, minus, that is negative 3 over 11 times 5 should give us 15 over 11. And therefore, that's what we have. Now, a matrix times identity is that matrix. And therefore, AB times the identity matrix is AB. And that is now 22 over 11, which is 2. And this